In this video, we're going to look at one of the harder topics of polynomials, known as polynomial long division. This video in particular is just going to introduce how to do polynomial division, and then in the next video we'll look at how we can apply that to solve some of the more complicated polynomials. For those who don't know me, my name is Chris Iannazzoni. I used to work as an engineer for a defence company, and I've since left that to start a career in tutoring. I make these videos so that VCE students can do the best they can in math methods. With that out of the way, let's get into it. Polynomial long division is a technique that we can use to simplify or factorise polynomials, and we use the following process to actually perform the division. Let's see an example. Suppose we have a division of two polynomials. The first step of the process is going to be to just set up the division as you see in front of you. Having done that, the first step of the sequence is going to be to divide the leading term of the numerator by the leading term of the denominator, which in this case is going to give us x cubed divided by x, giving us x squared. We're going to take that result and put it at the top of the division. This spot here is called the quotient. The next step of the division is to take that result and multiply by the entire denominator, which in this case is going to be x squared multiplied by x plus 2. This result is going to get put at the bottom of our division. The last step in the division is to perform a subtraction. We're going to subtract the term we just created from the term above it, and then just write the result below. If you've done that right, then the leading term should be 0. The power should always decrement every time. All we do from here is repeat the process. We're going to take the negative x squared that we now have as the new leading term and divide that by x, giving us negative x. Then we take that negative x and multiply by the entire denominator, giving us negative x multiplied by x plus 2. And once we expand that out, we're going to subtract that term that we just created from the term immediately above it, and then write that result below. All we got to do from here is loop that one more time. You know when to stop when you run out of x terms. And in this case, we're going to have a final result of 0, which means that our division was perfect. There was no remainder at the end. In the next example, we'll see what happens when we do have a remainder. But to finish things off, the actual result of our division is the quotient all the way at the top. So what we can say is that instead of f of x being a division of two polynomials, we can say f of x is just the quadratic at the top as our quotient. Now, if you had to solve this version of f of x, it would be much easier, since you just use the same methods that you would use to solve any quadratic, rather than having to solve a cubic divided by a linear. One complication is that you're not guaranteed to be dividing by a linear term. Sometimes you're dividing by a quadratic term. The good news is that the process doesn't change. It doesn't matter what your denominator is. You're still going to start by dividing the leading term of the numerator by the leading term of the denominator, which in this case is x cubed divided by x squared, giving you x. The next step of the process would have been just to multiply that result, x, by the entire denominator, x squared plus 1. Then, once again, you would expand that out and then perform the subtraction, subtracting that term from the term that was directly above it, and then writing the result below. We can actually loop this one more time with no issue. The issue comes about when we loop it for the second time, in which case we're going to have negative 15x divided by x squared, giving us negative 15 over x. The problem is that division by x. We're not allowed to have any divisions in our quotient. This is yet another criteria for you to be able to determine when to stop doing the polynomial division. So what do we do with the remaining term? Well, that term is considered the remainder. So when it comes to writing the new f of x, you start by writing the quotient, whatever that is, which in this case is x plus 1. Then from there, you write the remainder term, but you have to write it in a very specific way. You start by writing what the actual remainder term is in the numerator, and then you have to divide that by the denominator. And the reason why is because, well, this is the portion of the cubic that couldn't be divided. So it's going to have that division of our denominator. If you found this video helpful, then you should consider joining my free community. I host a Q&A call every week to personally help you through any of your specific questions, and you'll also get access to more resources like this, including written and recorded lecture content, as well as practice exams and SACs with detailed solutions. It's pretty cool. You should check it out. I'll see you there.